Alright, so now let's go ahead and discover a new functionality of this module Muffian. This time, for this example, I will be loading just one file. That is a file that we have seen before. And so this is just this temperature profile that we have time on the X and temperature on the Y. So on this videos, what I'd like to introduce you is a mod of the software. The software can be set up into different modes. So one mode is called individuals. It means that the operations that are set to individual blocks are only applied to the block itself here. So if we were to set plot xy on this block, this would be just the plot xy on this one, and if we were to set then derivative on this one, this would be derivative. But the input for each of these operations would be the initial values. So you will understand more when I will describe the second mode, continuous. So continuous mode, let's just have a look on how this behaves. If we were to click on continuous mode, this locks all the x, y, z columns. And so this time, the first one is always going to be plot xy. The second one, we can apply a first operation to this data. So let's just do an operation that we have seen before, which is adjacent average, with a factor of 15, let's say. We can update this. So we have this plot right now here. And now let's say we want to, for instance, calculate the heating rate. So the heating rate, it would be the derivative of the temperature with respect to time. So let's have a look here a little bit more on the area we are interested into by masking some of the data at the beginning of the file. And so this would be an operation, this derivative that we would apply on these data which have been smoothed already. So, because if you were to apply derivatives on a noisy data like this, your derivative value would be extremely noisy as well. So let's apply this derivative function. This time, because we are in a continuous mode here, this will be applied on this first calculated data. So you see here we have a value of the derivative. So a way to illustrate a little bit more why this is interesting is that you see here this is still a little bit noisy, so we could say, well, let's just increase a little bit this smoothing that we do on these steps here by saying we will put it to a factor of 25. And so if we apply here, you see the derivative plot is automatically updated. So again, for derivative, there is a parameter that we can set. So it's simply like a difference, so number of data that you take for doing a difference and calculate the derivative. If you were to increase that's the range, this would also provide a better quality on the data themselves. So just to summarize, this mode, continuous mode, would simply take the first sets of data, apply a first operation that could be anything from this list here, and then a third operation that could be again anything from this list here, and we have right away the data here that is displayed and calculated. So of course you can do that for a last operation if you wish. For instance, we could apply an operation that we have seen before, which is an interpolation. So if we were to do interpolation with this function ascispline, we would have then an interpolation of this derivative here. So let's just increase the point size so that you can see a little bit better. And then we will apply a blow function so that you see here this derivative function is up to date. So that's it for this video on this mode, which is called continuous mode.